All right. Hey, everyone. Welcome to another deep dive. Today, we have on a very special project. We have the streamer network. This is Henri. He's, I believe, one of the founders. Welcome.
Yes. Thanks for having me. Exciting.
Yeah. So before we kind of jump right into it, I guess how did you start the streamer network?
Well, it's a bit of a long story, but maybe compressed to just a few sentences. So I
Sure.
have a tech background. I've been working in all kind of areas from whatnot, e-commerce to finance and stuff. And back in the finance and trading days, I think I kind of realized that there's value in data, especially real-time data and streaming, because you can build automation and things like that. And then we started building basically like kind of Web 2 platform originally for IoT and that kind of stuff, but quite quickly realized that, hey, actually, if we want a platform that's kind of usable by anyone on the planet to kind of onboard to that protocol to unlock value in the kind of data streams, then it needs to be kind of open source, permissionless, probably needs some kind of incentive system to make it work and so forth. And around the same time, so this was like late 2016, we got quite interested about Ethereum and blockchains and smart contracts and that. And everything just fit together so nicely that we realized that, okay, if we really want to build this data infrastructure component of the future, then this is the way to go. So then from that point onward, it's the usual story. We started going to crypto conferences, made a white paper, raised some funding for the project. That was in 2017. So it's quite a mature project. We're still kind of building towards the end of our initial roadmap. Started out kind of on a 5-year roadmap to build quite an ambitious thing, and we're almost there. Like most of it is built and working, but there's still one milestone remaining that introduces like the full incentive layer and the token economics there. So
Well, yeah, I mean, I was shocked at how long the project has been around.
I know, yeah,
You
we're a
know, this
small team, so
No, it's not a bad thing. I mean, just even being in the space in crypto in 2016 is, quite a flex nowadays. And I think it really, and
even though it feels like it was just a few years ago,
for sure.
and it literally was. But yeah, as they say, 1 year in crypto is like 10 elsewhere. So
Yeah, well, I think like what was, whenever, because like you were looking, this was like back in 2016, 2017, even when you were raising money, like what was the conversation like back then around, what sort of inspirations did you draw? Because like there were no Oracle networks, there were no bridges, layer zero, I don't even think was a term.
yeah, layer zero didn't even exist. So it was much more about like on-chain use cases. And it still is a lot of it about L1s and stuff, but now of course we're much further in the scalability department. L2s, there are these alternative L1s, but we've been quite focused on the Ethereum space, mainly because, well, for many reasons, but especially because we started already back then, and Ethereum really was the only game in town and so forth. So yeah, it's amazing how broad the whole space is now, and there's lots of other like kind of off-chain protocols, IPFS and stuff like that, and kind of streamer broadly fits into that category and in the layer zero. But
Yeah, I mean, so like what was the original pitch though? Like how has that changed? Like what was the original thing that you guys would say back in 2016? Like we're gonna build, what was that?
it was quite similar, actually. Like we knew all the time what we want to build. We wanted to build like decentralized messaging infrastructure essentially. But in the beginning, I think we saw that especially IoT and data monetization and that kind of things would be like the drivers for adoption for this kind of technology. But IoT is kind of still waiting to happen. Everyone predicted that, there's going to be so many tens of billions of connected devices by 2020 or or whatever. But everyone's still kind of waiting for that to happen. Data economies haven't really been created in the sense that was predicted. I think everything has kind of worked or progressed much slower than anticipated in the beginning. But on the other hand, the whole crypto space has really boomed, and the end result is not really that like old existing enterprises would come into crypto and kind of connect with that stuff, which was what we thought in 2016, 2017. It's rather than the Web3 people kind of just built everything from scratch, and who cares about the enterprise adoption?
Right.
We have DeFi, we have NFTs, so kind of everything is kind of building on the crypto island instead of, I think,
well, I mean, for the
eventually
people,
they will,
like for the people that weren't there back in 2016, like I remember there was like, IOTA was a big driver, and it was the, your toaster was supposed to be connected to your refrigerator, and you were supposed to mine your own data and then be able to sell it on these marketplaces, and it would be, infinitely scaled blockchains that run the world. And
right. I mean, all of that I think is still on the table, but the adoption just has been slower, I suppose. And still, like, all the builders are basically the early adopters and the crypto curious, and still the big businesses are, almost nowhere to be seen. Like, of course, now the news about, Instagram enabling NFTs and, stuff like that, it's starting to pick up. But, I think it's okay. These things take a lot of time to build anyway. So, whether the enterprise hops on this year or next year or the year after that, that doesn't really matter, because building each of these protocols takes like several years. So I think the important thing is to kind of make progress and be ready for prime time, kind of when the planet is ready for this kind of technology.
For sure. Well, I mean, the tech has definitely advanced, and I think the conversation and the narrative since 2016, it's obviously much, much better.
Yeah, definitely. Of course, this year we've taken like steps back in the terms of like public perception of crypto, but maybe it's like 2 steps forward, 1 step back, and so forth. So we'll get there.
For sure. Anyway, all right. Thank you for that. Let's jump into how it works, though. I think before I start drawing, like, what would be like, what networks are you guys up on now, and what would be like a great example use case we can draw out now?
Yeah. Okay. So streamr is basically like off-chain, right? It doesn't require a blockchain to operate per se, but it does use a blockchain as a kind of companion thing on the side to manage certain things. And those certain things are basically like keeping track of permissions, using it for incentive, like token transfer, stuff like that. That wouldn't be possible without the blockchain. And for the blockchain part, we're using Polygon at the moment.
Okay.
So yeah, we used to be on mainnet, but then the gas prices went through the roof, and we moved to Polygon for that reason. But basically, it works kind of in tandem with the companion blockchain.
Cool. So like, I guess, so we'll draw over here, we'll draw somebody's smart contract over on Polygon. Smart contract on Polygon. And like, who would a user be? I guess what would be a use case for it?
Yeah, let's talk about use case. So
so let's say there's a user and they want to store boatloads of data off chain.
Yeah, it's not really for storage. It's more about real-time transport and broadcasting. So we're talking about pub/sub pattern. It means publish, subscribe. It's a messaging pattern. Maybe that would be the first thing to actually draw, just to understand like what the network does. So basically, like, publish, subscribe is a messaging pattern that connects data publishers and data subscribers over a topic. So maybe you can, build a topic or draw a topic in the middle, and publishers on the left side and subscribers on the right side, or something like that.
Yep.
Yeah, that's cool. That's perfect. Okay, so then the publishers, let's write topic into that ball or circle.
All right.
Okay, so that's a topic. And on Streamer, we call topics streams. So it's a stream, but later we can draw how Streamer works. But this is more like an abstract representation. So
of course,
the publishers send messages into this topic. So the topic is kind of just a way to, connect those who are interested in the same thing. So if you have, well, we talked about IoT, maybe I'll use that as a simple example. So if your toaster is connected, then your toaster would be the publisher, and someone else who's interested in the data from your toaster, then they would be a subscriber. And the thing in the middle is then the kind of system, right, that transports the data. And the traditional way to do this, like in Web 2 and in cloud, would be that there's just a centralized message broker. So your circle there that you drew would be just the server, like some machine running somewhere, and everybody connects to that. The publishers connect to that, the subscribers connect to that, and internally it then kind of match makes or brokers the data depending on who subscribed to what topic, and the message flows like that. But the problem is that it's a centralized point, obviously, and all the data goes through that, so it doesn't scale, not very robust against failures or attacks or whatnot. So it's not really something that we want to have in Web3, obviously. Plus it's everybody kind of needs to trust the system in the middle for anything to work, and access control is managed by whatever and so forth. So the idea of Streamer really is to replace that central part of in the picture with basically nothing at all. So it's completely removed from there, and rather the publishers and subscribers kind of connect peer to peer in more like a graph. So if we draw a different, well, maybe it's best to draw a separate picture of sorts, where let's draw more of those guys.
Draw separate. There. Okay, so we'll do the better model down here.
Yeah. And you can just draw those guys like across the thing. Don't leave a gap in the middle. It's gonna look cool.
Yeah, so they would just basically all be connecting to everyone.
Just random connections between the guys.
Like that.
And for example, and the cool thing is that there can be connections between the subscribers as well. So now it looks like the publishers are only connecting to the subscribers, but really everyone is connected with kind of whoever is there.
Yep.
And this particular way in which the nodes connect is called a topology. So that's basically like the peer-to-peer topology where the messages get distributed. So essentially, it's a system for broadcasting information or broadcasting messages. So if the publisher creates a message, they send it to a couple of peers in this topology, and each one of those peers sends it onwards to other peers who are connected. So it's not just publishers sending it to subscribers or this centralized system which we would have in the cloud version of this, sending it to subscribers, but really like publishers are sending messages to each other and subscribers are sending messages to each other. So that's also why it scales. So imagine the top picture where you'd have like 1 million subscribers, right? You just have like a ton of subscribers in the top picture, and everyone tries to connect to that central server. and eventually at some scale it will fail. It just won't be possible to serve everyone. But in this type of peer-to-peer network, since basically like if you're consuming a resource from it in terms that you want some data, you're also giving the data onwards to others. So so basically instead of 1 million people having to connect to a single source for the data, basically everyone can connect to 4 friends in the topology and send the data to them, and then they will send it onwards to 4 other people, and so on and so on and so on, until everyone's gotten the
maybe one way, I guess, to think about it, like maybe if you can compare it to other systems. So like, would you compare it, I guess, would like libp2p be a competitor then?
Yeah, sort of. libp2p has a lot of stuff in it, but one thing that they have in there is also like a pub sub system with a couple of like sub protocols in there. They have flood sub, gossip sub, and whatnot, and it's quite similar. One difference there is that streamr adds a little bit more of like more high level things. So if you look at libp2p pub sub, it's just the lowest layer. It basically enables you to send like raw bytes, but it's not very opinionated at what that content is or how the applications should use it and so forth. But in streamr, we kind of build on top some things like the access control, especially, which creates one connection to the smart contract stuff that we can talk about in a bit. And we have like end-to-end encryption built in. There's a key exchange mechanism, which basically works in tandem with the end-to-end encryption, so that if a new subscriber shows up and they don't have the key to unlock some data that they're supposed to have access to, then they can obtain that key from the publisher in a kind of automatic way. We're opinionated on like what's the actual order of messages. If a publisher sends 1, 2, 3, 4, then it's nice if the subscriber can reconstruct that 1, 2, 3, 4 order instead of getting like 4, 2, 1 and 3 not at all. 3 would just be in a black hole somewhere.
Well, for like for the other people listening, like another one that they may have heard of would be like, would you compare it to like maybe a BitTorrent?
Yeah, it's quite similar, but BitTorrent would be for sharing static files, obviously, whereas streamr is really for propagating messages to some audience. So you could think like easy use cases or easy to understand use cases for streamr could be a chat. Imagine a WhatsApp, but in a Web3 way. You could have chat rooms, chat groups, right? Which are like topics. There can be a bunch of people. Everyone can be a publisher and a subscriber at the same time, which is how typically these DM
I
groups
mean, let's
work.
build that. Let's try and build out a chat app, I guess, on streamr. So would it start? I'm guessing if it's a Web3, let's say you have a Web3 community and they have a token on the Polygon network, and they want to build a chat where it's a chat app for token holders of their community.
Okay.
Yeah. That makes sense?
Kind of. Yeah. Why not? Why not?
Okay.
Yeah. It's really like everything is the same. It doesn't really matter. It's a very broad range of use cases that can be used. But yeah, we can walk through that kind of use case, definitely.
So what would you say we set up first?
Yeah. So obviously this kind of use case would need some kind of front end where the people can actually use.
We're assuming we'll assume they're all phenomenal coders. They can send messages via code and they're fine with command lines. Now.
So let's assume this thing works in a browser, right? So you're gonna have a chat in the browser. So you're gonna have like a web page essentially that acts as the client, and what the developers will do Yeah, I don't know how you want to draw this.
Yeah,
but
no, okay,
let's
so
build an application. What does a chat application look like? You know, it has a
yeah.
room with a bunch of messages in there, right?
So like I guess the question would be, you know, who would right now it would be with a pub sub subscription, you know, like I guess we can get into the access control because I think that's sort of where you differentiate.
Yeah,
Because like
yeah,
the problem with like, you know, like even on you know, when we were talking Redstone, you had you had them sort of using you guys as pseudo data storage slash messaging layer, right? For
yeah,
real-time data.
yeah, yeah.
The problem with if you were just doing that and building it on like a base pub sub model would be like there's no spam proofing, right? You would just
Right, right.
anybody could go and post and you would just be completely obliterated with spam and there would be no protections,
Yeah,
right? And I'm guessing
yeah.
you guys fixed that.
Yeah, sort of. So one thing
Okay.
that happens on the streamer network, which is actually very important, is that all the messages are signed with a private
Okay.
key. So the identity system that we have on streamer is the same as on Ethereum. So basically all Ethereum addresses and Ethereum private keys are also streamer addresses and streamer private keys, right? Which creates a very straightforward connection in the sense that if you see a message posted on streamer, it's going to be signed, and it's going to be signed by an Ethereum address, essentially, right? So, you know, if you know that address 0x123 is, you know, your friend that you're chatting with, and you see a message that is signed by this 0x123, you know that for sure it's from your friend. It cannot possibly be from anyone else. It's impossible to kind of spoof messages, right? Because everything is signed.
Right.
And
so this would be like the Oracle use case. You could say like if you had a smart contract on Polygon, you could come in and whitelist, say on 0x123, 345, and 6, 7, and 8. You know, these are all addresses. You could basically just grab. You have basically these
right,
people could pass around messages that are prices, and then when you want to use them, you could just grab those signed prices and throw them in here.
right. In an Oracle use case, basically anyone could provide that piece of data to the smart contract because it doesn't matter who provides it. It's signed, it carries the signature with it. So that's what makes it useful for Oracle use cases, that the provenance of the data is kind of built in. If you have a set of addresses that are kind of valid sources of that data, and you see one of those, then you know, okay, for sure this is like a true and correct piece of data.
Right.
And
then
so that's important for oracles, but also in the, you know, the imaginary chat application between people, it's equally important. You know, you don't want to be guessing like who is the counterparty. You know, you have a lot, you know, there's a lot of like scammers on Telegram and so forth, and you never know, you know, they reach out to you and they're pretending to be someone or whatever. You know, you wouldn't make any kind of business deals with them, right? But if you have the confidence about who the other party is, you can kind of act with more confidence in that situation.
So that would be similar to like a gossip network, you would say, where you pick the people that you have and then you can connect graphs building it that way, right?
Yeah, I mean, let's go back to this imaginary chat
Sure.
example.
Imaginary chat.
So yeah, okay. So now I have you on the line, so I know that you're you. And now if I asked you like, what's your Ethereum address? And, you know, I'd add you to a chat room, and a chat room is now basically just a stream with where you can have publishers and subscribers, but let's assume it's just you and me at the moment. We're just alone. It's a one-to-one DM, right?
Yep.
So after I see any message in that chat room, I can look at the signature and verify that it is in fact coming from you, essentially. We exchange our addresses, and then that it can't be from anyone else. And this creates an interesting model where you can actually leverage the composability of smart contracts, which makes for a quite interesting feature in the sense that, okay, now we have a chat room with just you and me in it, and we communicated our addresses and our trust out of band in this call, right? But what if you could build a system where you have some kind of on-chain criteria for being able to join a stream or a chat room? For example, if you have a particular NFT, for example, or if you're a holder of certain tokens, then you can automatically enter this chat room, an exclusive club for anyone who has a Bored Ape NFT or whatever. So that kind of things become very possible thanks to the kind of on-chain access control, which gives the composability benefits, as well as using the Ethereum addresses as identities, because then it's very straightforward. If you have address 0x123 and address 0x123 has the Bored Ape NFT, then it's very easily validated. And when messages come in that are signed by 0x123, then it's obvious that, okay, this all works together. It closes the loop.
Cool.
So I think that's what kind of adds a lot of value into human-to-human messaging. But then, of course, you have the whole sphere of machine-to-machine on the side, and the protocol itself doesn't care whether it's your toaster or you yourself who's sending messages. It does exactly the same thing that it always does, which is basically transporting the data across this topology or set of peers that kind of together collaborate on distributing the data across the network.
Sure. So I guess the next question would be, okay, so I think I got a good idea of how it could potentially work, or some apps for the chat users. What do they have to pay to use this service? Is there any sort of payment?
No, the basic thing with the streamer protocol is that it works on that reciprocity that we were talking about earlier. So the subscribers give the data to other subscribers. So it's kind of tit for tat type of system that, hey, you get a message, so why don't you give a message to your friend as well, and they return the favor, and it works like that. But of course, without incentives, it's a little bit unreliable. So if you kind of have a topology or a stream where participants are, they will follow the rules of the protocol, then okay, it will work just fine. But if you have a critical use case, you might want there to be a ratio of honest nodes who are doing this work of propagating the data onwards, as opposed to potential nodes that maybe they're a bit lazy, maybe they don't give the data to the peers, they just take it themselves but don't send it to anyone.
Well, I think one great example that people watching this know Ethereum would be MEV. So you broadcast a message to the network that says, hey, I want to do this trade. The first subscriber who listens to it says, that's a great trade. And then he starts passing his own signed messages, and he drops yours, right?
Right. right.
Like, would that be
So
possible, I guess, here, or would there be rules to sort of prevent anything like that from happening?
yeah, there's a lot of redundancy. So if you're a publisher, you basically send the data to 4 peers first.
Okay.
And if all of them, the attack would really be like censorship, that they don't propagate your data anywhere.
Yep.
They're like, I don't like this message, I'm just going to drop it or something. But all those 4 would need to be these bad guys in order to censor the publisher. And it's kind of hard to target a particular publisher also in the network because the connections are random. So you don't get to choose who your neighbors are. You're kind of forced into a certain pattern. So this prevents potential bad actors from eclipsing a certain publisher. And so
Well, is
forth.
there anything, I guess, to prevent, like a Sybil attack type thing, or millions of people upon entering to?
Well, it's kind of tricky. Like there's a couple of type of attacks that can be used in this kind of system, and all of them are kind of variants of the Sybil attack, that you would just basically like generate a lot of
Yep.
nodes into the network that are somehow malicious. So and that is certainly possible, and that's also one reason why you want to have like a certain ratio of honest nodes to kind of counteract potential attacks. And that's where the incentives come in, really. So as I mentioned, the system can work for free on the reciprocity principle, but what if you incentivized some nodes? They're not interested in the data, they're just there to kind of make your stream more secure, right? So they
Well, I mean, in here, like you could say, like for an example, like this, you would want to make sure like this would only work. Like you could obviously both be online at the same time and pass it over to each other. But
yes.
like if
What
you
if there's
propagate
more
a message
people?
and then drop
Right.
off the network.
Right. Well, there's that. And like if there's just 2 people, sure, they can connect to each other, but not necessarily in all circumstances. So
Right.
maybe we are behind some really tricky firewalls or something, so that we simply cannot form like a peer-to-peer connection. And in that case, it's also useful if there are others in the topology. So maybe we can kind
So
of,
if there were people here who
yeah,
who could get it, pass it
right,
around.
right, exactly like that. And now,
then this would be encrypted, and only this guy could read it.
Exactly.
But right.
Exactly. So for like confidentiality of data, encryption keeps it confidential. So we can kind of add as many middlemen as we want into the
Sure.
topology. But if those guys, the ones that you just added there, if they are now attackers, and they wouldn't pass on the message, then obviously, again, we wouldn't be able to communicate.
But hopefully you could just broadcast it to a wider array and eventually.
Right. But how do you get that wider array of nodes? You maybe need to incentivize them to join, right?
Let's get into it.
Yeah. Okay. So imagine now that these guys who you added are attackers, and maybe we can cross out the lines between the 2 of them, for example, or like that. Yeah. Right. Sure. Okay. Now we can't communicate anymore because these guys are bad, right?
Yep.
Hey, let's hire some honest folks to join. So I'm gonna put a bounty. I'm basically like gonna put down some tokens. Like, hey, anyone who
this is on Polygon, right?
Yeah, this is on Polygon, and this is coming in the next milestone, actually. So it's not quite like this yet. So cool. This is how it's going to be like next year. But now I'm going to say like, hey, everyone who joins to help with, the message passing in the stream will get, 100 data tokens per day or whatever. So there's kind of stream of tokens up for grabs. And now let's say that you have the technical ability to run a node. So you'd basically like now join this picture as an, well, basically you'd put down a stake. Let's do that first. So yep.
So you would put down a stake.
You put down a stake. It also goes into a smart contract, and you say like, all right, I'm going to help you out here. You're going to join this topology, and you're going to start forming connections again to peers in the network. Maybe there's like, yeah, right.
Yep, we bypass that dishonest guy.
Yeah, we bypass that dishonest guy, and everything still works.
Yep.
Now, obviously, because the connections are random, so you can't really choose your neighbors in that sense. It's good and bad. So you can't choose only honest neighbors necessarily, and you don't know who the honest neighbors are anyway. So your bet is basically that there needs to be enough honest nodes in the topology compared to the lazy ones that don't pass on the messages. And in that case, the message flow will continue uninterrupted.
Yep, and then you stream the tokens up to that guy for basically exactly as long as he stays connected, or
and
so I guess
and there's a validation procedure that, okay, how do we know that this guy is now how do we know that you're doing the work honestly? So basically you can go and ask their neighbors. So it gets a bit complex, but basically you can ask their neighbors like, hey, is this guy sending data to you? And if they say that yeah, everything's fine, I'm getting data from this guy, then you can basically deduct at least a subjective opinion that, okay, this is a good guy, and also vice versa. Like if you see a bad guy in the network, you can ask their neighbors like, are you getting messages from this guy? And no one's getting any messages from that guy, so they are probably some kind of attacker or free rider.
Okay, so let's just walk through that. Let's say this guy was streaming and he's getting these rewards, but he's front running this guy and he's not sending his message.
Yeah, so then
what would this guy do?
Yeah, you can basically challenge, like the details of this procedure are still like work in progress. So we can talk about it on a high level, but this guy can basically challenge that, hey, I don't think this guy is doing the right thing in the network. So he kind of raises a flag there and probably puts also a stake to back up their claim, like, hey, I inspected this guy, he's not doing the right thing, and here's a bunch of tokens to back up my claim.
Yeah, like a dispute fee.
Yeah, it's a dispute fee.
Yep.
And then what needs to follow from that is some kind of dispute resolution. And there's a couple of different approaches, and we haven't yet like locked down on a particular approach. But for example, the others who share this kind of are also working on the stream. Like in our picture, we only have this one guy who's staked, but in reality, there will be several. There might be 50 nodes in there who are all working in the stream. So then they can do that same inspection process and check. It's kind of like, hey, I don't like this guy. I don't think he's doing the job. But if you don't believe me, then you can check it out for yourself. So others who have an interest in servicing this stream properly, they can go and check whether this guy is doing the work. So
like, would there be an easy way to check? Would it be like sort of pretty obvious if he's not doing it?
Relatively easy. It's not trivial, but it can be done. But the tricky thing is that you can't really have proof of it that could be presented to a smart contract on chain. So it needs to be some kind of, for example, voting. Somebody raised the claim. I don't like this guy. What do the others think? Well, maybe some of the attackers will vote that, okay, these are honest, because of course they don't want to vote themselves out. But the honest ones there will then vote that, hey, let's kick out this guy. And
you could always use an oracle. I know a really good one you could use.
Yeah, but distributed truth is very hard.
Super hard.
It's very hard. But anyway, so if this guy is then found to be guilty either through this vote or some other kind of dispute resolution, then they can get kicked out from the stream and their stake would get slashed.
Slash. Don't slash. Yep.
Yep.
So yeah, but I mean, if you need help designing this one's what we do. But yeah, so I think that would
Okay.
that makes a lot of sense now.
Yeah, the tricky part is exactly that validation and coming to a conclusion about who's doing the job properly and who's not, and that's something that we're right at this moment.
Well, because this is the
basically
so
working
like if he publishes and then publishes a challenge, how do you prove that he's not sending your messages? It would be because like I might be over here sending him messages and he sends them, but he just doesn't like this guy.
Right.
So
So you'd have to ask, like,
Yep.
but yeah, but every if the message flow in the network is working, then it means that at least every honest party will have all those messages, so they know kind of the right answers of what messages have been in the stream and how many messages from a certain publisher and so forth. If you have some honest peers out of the 4 or whatever peers you have, then you're going to be getting those messages.
Could this guy manually add a peer? Could he say like, I definitely trust this guy? So
yeah, basically he could. Like that's possible, but both parties need to consent to that connection, because normally
I know there's like in the gossip networks, there's like those hubs, right?
Yeah, but then the hubs kind of would create sort of like points of failure, or
Sure.
we like to keep it kind of more uniform, but of course you can make some kind of best pals forever deals in the network, that okay, at least the
Right.
two of us always trust each other and and so forth. But it's not really needed. Like you don't need to know who the peers are or trust them. The only thing that you want to trust or hope for is that that there are enough honest peers in the topology compared to dishonest peers, and that's basically it. Because you can always switch peers. Like if you don't like someone, just disconnect and get a new one. It's possible. So you're not stuck with particular peers, but it's also kind of hard to fully determine in advance like who's honest and who's not. But really it doesn't even matter. Like there's so many failure cases in peer-to-peer networking that someone's going to have a bad connection and some messages get dropped because of that, and they're not really attackers or dishonest, they are just unable to do the job because whatever they're they ran out of power, or
so you would hope that they don't get slashed in that scenario.
Yeah, and they wouldn't, because they're not even trying to kind of mine the bounty. They're just there to maybe as subscribers or whatever. But those who are actually putting a stake in there and earning some money out of it, they are kind of promising that, hey, I'm stable, I'm not like behind a 4G network connection or something. I'm reliable node, I have uptime, I have internet bandwidth and so forth. So they're putting their money on the line to guarantee that, and that really helps like to defend against attacks and other like unwanted things, like just bad connections in the network.
Well, I mean, this is very similar to like in sort of like an ETH layer 1, where they would stake and then they sort of promise to be live.
Right, exactly. So it's very similar pattern, but the job that they are doing is a little bit different, right? So in this case, they are sending messages, so they're kind of contributing bandwidth to the network, whereas in in a blockchain or a proof of stake system, you're basically just confirming like hashes. Basically, you're redoing some computation to check that things are valid. But in this case, you're just more like shoveling, you're shoveling data from one side to the other side, and that's your job.
And this would, and in this case, like I guess as the network fills up and more demand is sort of required, you would expect more payments to be pushed through, so that way it would incentivize more people to jump on board and more bandwidth.
Correct. Yeah, and it depends on kind of what kind of service level you're going after. Like if if best effort is enough, then you can go with the free thing where, you know, you're relying on reciprocity and so forth. But if you have some kind of business critical stream, then you probably want to pay a bit more to, you know, get that reliability going in there. And it's not different from the concept of paying for a cloud service.
Sure.
Like in the very first picture, the centralized picture that we kind of draw there, that would normally be like some service. You would take it from, you know, AWS cloud or Azure cloud or some dedicated provider to kind of get this thing going. But in the case of streamr, it's obviously peer-to-peer, but it doesn't mean that paying couldn't make it better, right? So still there's value in these incentives, but it's just kind of very different from how the centralized thing works. But
yeah, well, I guess on the incentive piece too, like how would, I don't know if, like how would you prevent this from becoming cloud providers? You know, like you could assume if the network and the bandwidth gets so large that you would, to run one of these nodes, theoretically, it could be really, really large. And maybe.
Could be, but on the other hand, it's not very resource intensive. Like if you run a blockchain node, you're gonna need like tons of memory and disk and CPU to just do the computations to validate the chain. But in the case of streamr, you're more like just shifting data around. So, you know, you could potentially do this mining type of operation on a Raspberry Pi device or something very lightweight. So it's not really like intensive at all. And you can kind of choose which streams you would mine. So we drew this smart, okay, I'm pointing with my finger, but yeah, of course you don't see where I'm pointing.
No.
But anyway, like there's going to be a bunch of these contracts that we call bounties for different streams. So it's kind of like on the graph, you have the different subgraphs, and then the nodes who are the workers there, they're called indexers. The indexers choose which subgraphs they want to index and kind of collect the money from there. So in streamr, it's very similar. So if you're running like a node for this mining operation, then you choose which streams or which bounties you want to join, and you can kind of fit that to your capabilities. So, you know, if you are running on a Raspberry Pi and you don't have a ton of bandwidth or whatever available, then maybe don't join all the streams in the whole network. You know, just join enough
a few you
to
can
saturate your capability, and then you're kind of maxed out. If you try to kind of bite off more than you can chew, then you might get slashed because you're not doing it reliably anymore.
Cool. And then I guess I have to ask, this is my thing. Do you do inflationary rewards? Any sort of
we do. Like the inflation model is not yet confirmed for this next milestone, but in the current model, what we have kind of like a precursor of this live at the moment, where the whole network supports obviously this reciprocity thing, so the free thing, the kind of base layer, right?
Right.
And then we have a couple of kind of special streams that already today have incentives. So this kind of thing is happening today, but not yet in any stream in the network. So there's like predefined streams that can be mined, and there's like a 2% per year inflation. So it's very, very moderate in that sense.
Go crazy! Come on.
Yeah, exactly. But the token holders, so we have basically like a snapshot-based governance voting model where the token holders get to decide what the incentives and the inflation rates will be. And for this next milestone, where basically any stream can be incentivized in the way that we just drew here, then you know, those incentives have not yet been decided how it's going to work. But probably it's going to like rather like start with something and then go down over time, because I think it's really beneficial that these type of networks and protocols can kind of bootstrap in the beginning using these inflationary rewards, and then over time that gets replaced with kind of organic flows of tokens where actually there's somebody who pays into the bounty for someone to be able to earn it and so on. But in these protocols, it never happens on day one. So, it makes sense to build that kind of supply side first so that there's some activity on the network and so on. It's really powerful.
No, I love inflationary rewards for Bootstrap.
Just look at Helium or something, how they kind of built out the whole network just by kind of bribing people with tokens.
I mean, synthetics, same thing.
Yeah, exactly.
Dude,
so it's really brilliant. And the danger there is kind of, I guess, to go overboard with it, that you don't want to be like doubling your supply every year or something like that. So
honestly, in this space though, it's really weird because honestly, like if you want a shot at usage, it's like a prerequisite to getting usage, or at least some attention. So it's always like, I'm all for it. Go hard and go home.
Yeah, well, let's see.
But this is this was super good. I can I will stop my pin. So, but this was I definitely think I love the idea. This was my first time actually deep diving into a layer 0 or sort of a peer-to-peer one. So hopefully I didn't ask too many stupid questions.
No. I think we covered like everything in a really, really nice way. Like we covered the basic thing, how the message propagation there works, and then we covered the incentives and why there are incentives, right? That's an important question as well. Like what do you get for paying some tokens? And basically you get like more security and more robustness.
Liveness guarantees, things like that. So no, it's super cool. I'm glad there's people like you working on these underlying problems. What would be, I guess, what's the next steps for you? Obviously you're launching your incentive token and pieces like that. What blockchains do you work on now? What's sort of the plans going forward on that?
Yeah, so just to clarify, the token already exists, but it's just not used yet in this exact way that we drew there, but it exists. It's called the data token, streamr data token.
Congrats on getting that symbol. That's good.
Yeah, well, if you start in 2017,
I know.
you're gonna have like good names available, right? So you're able to grab that, but yeah, there's that. So how do we, you asked about next steps. So definitely we're like working towards what we basically just drew here. So building these smart contracts, and especially that validation procedure, which is basically like that's like the tricky bit there. So working on that. Also, like at the moment we have kind of utility nodes called trackers. We didn't draw them here because a bit of a distraction, but it's similar to trackers in BitTorrent protocol. So they are basically like helper nodes that help these parties find each other. You're like, hey, I want to connect to this guy, but I don't know where he is on the internet. So the trackers kind of help with that kind of thing. But it's possible to also remove the trackers by adding a bit of complexity and doing the kind of peer lookup over a distributed hash table or DHT. And that's also something that we're working on at the moment, because these trackers, while they work well and they're very efficient, they kind of create also points of failure, like not single points of failure, but limited set of points of failure. Like right now in the network, there's 10 trackers. If one goes down, it doesn't disrupt the whole network or anything like that. But we'd rather not have the trackers at the end of the day. So that's also something that will come in the next version. And the on-chain stuff, where we have the permission management and different layers on top, like there's monetization and higher level frameworks like that, it's probably gonna like stay pretty Polygon focused for now, but some of the things will be available kind of multi-chain as well. For example, the monetization stuff, which It's called the marketplace. You can basically like sell access to a stream in there.
Yeah,
That's
but
kind
I
of
mean, they
working.
are
Yeah,
they're basically just signed EVM messages, so you could
sort
or
of. Yeah, if you have something to transport them like from chain to chain, because at the end of the day, your permission control is in the Polygon chain.
Yep.
So if something happens on another chain, like let's say Gnosis chain or Optimism or whatever, you kind of need to know about it on the Polygon chain at the end of the day, because that's the reference point for checking like who's allowed to publish into a stream and who's not. So getting that thing going is one part of the system. So even though we only talked about the streamer network here, we have like a kind of higher level applications that are targeted at certain use cases, like the marketplace for monetization, and then we have a data unions framework, which is basically for data crowdsourcing type of use cases and so forth. But this is really the main protocol that is the streamer protocol.
Super
and
cool.
the streamer network.
No, very I like it. I got a few ideas kind of hashing it out with you, so I'll continue to think about them. But yeah, I guess where can people go find out more?
Yeah, the project website is streamr.network, and streamer is spelled exactly like you spelled there. So without the last E, at some point these misspelled names were trendy. Plus, you'd be able to get the domain names for the misspelled ones. So yeah, streamer spelled like stream and then R and no E in there. Streamer.network. Cool. That's our project site. And please feel free to join our Discord, ask questions. Our direct users are usually like developers, so it's not really like a retail thing. It's for builders. It's for devs.
But you can come on and run. Pretty soon you're gonna be able to come on and make some money, right?
You can already. So as I mentioned, already in the current network, we have certain predefined streams where this exact thing is already happening. So you can earn by running nodes already today. And in the next milestone, it will just get like a bit more diverse, but that's cool. It. The principle is the same.
Awesome. Well, yeah, thank you so much for being on. And yeah.
Thanks a lot. I had a lot of fun. So thanks.
Cool. Yeah, let me